Hello everyone. Let's now look at chapter 4's practice problems together. So we're going to use the following data set, which contains the speed and the distance traveled before it makes a stop. And we want to answer the following questions. So we have this data set contains speed, and we have the full column, the data of the variable speed, and then the data of the variable distance. And then the column are data values for the variable distance. So two columns and of course two variables. The first question, I want to calculate the mean of speed and the mean of distance. So let's first use a variable to represent speed and distance. For example, we want to use distance as variable y and speed as variable x. So the mean of speed, so that's x bar, right? That's for speed, x bar, equals sum of x over n. So I'll have to look at the column. The data for speed, we have 4 plus 4 plus 7 plus 7 plus 8, which is sum of x, and over n, 5, right? We know n equals 5. So then we can use our calculator to calculate the sum, right? So let's type it in. 4 plus 4 plus 7 plus 7 plus 8. So that gives us 30. So that's 30 over 5. So that's x bar, the mean of speed. What about y bar? The mean of distance. So that's sum of y over n. So we have 2 plus 10 plus 4 plus 22 plus 16 equal divided by 5, and the sum equals, let's use the calculator. So 2 plus 10 plus 4 plus 22 plus 16, 54. 4 over 5, 10.8. So that's 54 over 5, that's 10.8. So that's our y bar. Then we will answer question 1. Question 2, want to calculate the standard deviation of speed and distance. So for speed, we have standard deviation of x. Let's use the shortcut formula. So standard deviation's formula is square root of sum of x squared minus sum of x squared over n, and the difference over n minus 1. Don't forget to take square root because we want to calculate the standard deviation. So now let's see, do we have sum of x squared? We don't have it, so let's calculate sum of x squared, which is 4 squared plus 4 squared plus 7 squared plus 7 squared plus 8 squared. So that is, again, calculator, right? So we have 4 times 4 plus 4 squared plus 7 squared plus 7 squared plus 8 squared, which is 64. So we got 194. So 194. So similarly, we can calculate sum of y squared. So that is 2 squared plus 10 squared plus 4 squared plus 22 squared plus 16 squared. So let's see what it is. So we have 2 squared plus 10 squared plus 4 squared plus 22 squared plus 16 squared. So we got 860. 860. And the sum of x and sum of y, we have that already. So 30 is sum of x, and 54 is sum of y, right? So now let's plug in. Sum of x squared, 194, minus sum of x, which is 30 squared over 5 divided by 4. So that's square root of what? Let's see the variance first. (194) minus 30 squared divided by 5, and that divided by 4. So we got 3.5. Then we have the standard deviation. 3.5. Take square root, which is the power to the power of half. So which is 1.8708. That's the standard deviation of x. Similarly, we can calculate standard deviation of y, right? So square root of sum of y squared minus sum of y squared over n minus 1. So we have square root of 860 minus 54 squared over 5. The difference over 4. So again, first we calculate the variance. So we have 860 minus 64 squared over 5. And then the whole thing, the difference divided by 4. 69.2. And the standard deviation is square root of that. So 69.2 square root. So 8.3187. Okay, we finished question 2. Question 3, we want to calculate the correlation coefficient. Correlation coefficient. So the formula for that is R equals 1 minus n minus 1 sum x minus x bar over sx times y minus y bar over xy. So that's going to be 1 over 5 minus 1. N is 5, right? We're going to take a big sum. So first x value, we have 4, 4, 4, so let's write it out. So we have x, which is 4, 4, 7, 7, 8. And then for y, 2, 10, 4, 22, 16. Okay. So the first x value is 4 minus x bar, which is 6. And y bar is 10.8. So first x can take 4 minus x bar, which is 6, over sx, which is 1.8708. times y, 2. The first y is 2 minus y bar, 10.8 over standard deviation of y, 8.3, 187, and plus a second term. So x is 4 minus x bar 6 over 1.8708. Y is 10 now, right? 10 minus 10.8 over standard deviation of y, which is 8.3187, and plus the next one, right? So we got a 7 for x minus 6 over 1.8708 times y is 4 now, right? Minus 10.8, which is y bar, over 8.3187, and plus 7 minus 6 over 1.8708 times 22 minus 10.8 over 8.3187. And then the last term, 8 minus 6 over 1.8708 times 16 minus 10.8 over 8.3187. That's a big sum. And then divided by 4, that's our R. So 1 over 4 times the sum. And now let's calculate the sum. Use the calculator. So we have 4 minus 6 divided by 1.8708 times 2 minus 10.8 divided by 8.3187 plus 4 minus 6 divided by 1.8708 times 10 minus 10.8 divided by 8.3187. And then we plus the third one. 7 minus 6 divided by 1.8708 times 4 minus 10.8 divided by 8.3187 plus 7 minus 6 divided by 1.8708 times 22 minus 10.8 divided by 8.3187, and the last term, 8 minus 6 divided by 1.8708 times 16 minus 10.8 divided by 8.3187. Okay, the sum is 2.1847. And don't forget, divided by 4, so 2.184722 divided by 4. So we got 0.5462. And this is the correlation coefficient. Okay, question number 4. I want to use speed as the explanatory variable. So that's our x. And response, we use y represent response. Distance is y. So when we calculate the correlation coefficient, we happen to have that xy set up. So we can still use what we have, what we have calculated already. So now we want to find the least squares regression line, right? So the least squares regression lines formula is y hat equals b naught plus b1x, where b naught, we should write down b1 first, which b1 equals r times sy over sx, and b naught is y bar minus b1 x bar. So now let's just plug in what we have. So b1 is r 0.5462 and times sy over sx 8.3187, and sx is 1.8708. So that's our b1. So let's calculate 0.5462 times 8.3187 divided by 1.8708. So we got 2.4287. That's our b1. So b naught is y bar minus b1 x bar. So y bar is 10.8 minus b1 2.4287 times x bar. X bar is 6. So now let's plug in. So 10.8 minus 2.4287 times 6. So negative 3.7722. That's our b naught. So then we can rewrite y hat equals negative 3.7722 plus 2.4287 x. So that is the least square regression line. And we want to interpret the slope b1. So we're going to say for every 1 unit increase in x. So x is the speed. In the speed, the distance, right? The y, the distance. Increase, or we say change positively because b1, the slope is a positive number. The distance increase 2.4287 unit. So for the question, if we do have unit, then we can plug in the unit. If we don't have, then we just put a unit, the term unit there. So the distance increase that much on average. That's the interpretation of the slope b1. Question number 6, the last question. Find the predicted distance when the speed is 5 and interpret the result. So we know y hat is negative 3.7722 plus 2.4287 x, right? So then we plug in speed is 5. So when x equals 5, y hat is negative 3.7722 plus 2.4287 times 5. So let's see what it is. Negative 3.7722 plus 2.4287 times 5. So that is 8.7, I believe. 3713. 8.3713. That's the predicted distance when the speed is 5. So the interpretation, so for speed is 5, the average distance for speed equals 5. The average distance is 8.3713. We can put it in there. Okay, that's all 6 questions for this worksheet 4. If you have any question, please email me or attend the Zoom meeting at the office hours. Thanks for watching.